let's take the case where we need to factor x squared, pardon me, that was the last one, n squared. Yeah, we can leave it x. Plus 7x plus 16. Now in this case, the product we're looking for, again, remembering there's a 1 out here, is going to be a positive 16, and the sum is also going to be 7, as in the last case. So we will make a table, product 16, sum 7, and we'll see what we can do with this. Again, I'm going to start with 1 times 16 to demonstrate a little more how this works. Our sum, 1 plus 16, is not even close, 17. We can try 2 times 8. 2 plus 8 is going to get us 10. And we can try 4 times 4. 4 plus 4 is 8. And we're out of factors. We have no more factors of 16 to work with, and none of them added up to 7. The table is very useful in that when this happens, you can say, I can't factor this. You would say that this, after making your table, this is not factorable using integers. You could also say this is a prime polynomial. Just like you have prime numbers, where the only factor is the number itself and 1, numbers like 13. 13 you can factor as, if you make an old-fashioned factor tree, 13 and 1, and that's it. That's a prime number. You have a prime polynomial here because you can't factor it out. Your product sum table shows that you're not going to be able to undo your FOIL. Now, we're going to extend what we've been doing. So far, we have done the special case where we didn't have to deal with anything other than plain old x squared. We're going to extend that and put something other than 1 in front of the x squared. A will be something other than 1. That is another way of saying it. We'll use the same method. And we will factor 4x squared minus 4x minus 15. Now, our product is going to be 4 times negative 15, which is negative 60. And the sum we're trying to find is negative 4. So we're looking for factors of negative 60 that add to negative 4. And we'll just start with our table. Our product, negative 60, and we need factors that add to our sum of negative 4. And I already know 1 times 60 is not going to do the trick. I want to kind of shift toward the middle, factors that are a little bit closer to each other. So let me try something like 3 times a negative 20. I'm putting the negative sign on the number that looks bigger. It's actually further to the left on the number line, but it has a larger absolute value because I know I need the sum to come out negative. Well, 3 minus 20 is going to get us negative 17, so that's not it. Let's try getting these two numbers closer in magnitude. Let's try something like a 4 times a negative 15, which is where we started out to begin with. Well, 4 minus 15 is a negative 11. Still not there. And moving right along, let's try 5. 5 will go into 60. So let's take a 5 times a negative 12. 5 Minus 12 is going to get us negative 7, getting closer, but we're still not there. We're after a negative 4. Let's try 6. 6 times a negative 10 is going to give us what we want. And, you know, on good days, you might see that immediately, and on not as good days, it might take a few tries. But your table leads you to the factors of interest. Now, what we're going to do, instead of jumping to the factored form, we're actually going to have to undo our FOIL all the way. So our second step is to rename. And we're going to rename the middle term. So we had 4x squared minus 4x, and I'm going to write this as plus a negative 15. We're going to take the negative 4x, let me get this back on the screen here, and rename that as 6x plus a negative or minus, whichever you're comfortable with, 10x. So we're taking these factors, and what we're doing is we're saying, when I FOILed, I had those two middle terms added up, the O and the I. This is the O and the I right here. And we're going to rewrite the simplified negative 4x as the outside plus the inside from the multiplication that we're walking backwards towards. And we keep the 4x squared, and we keep the negative 15. Now we've got this, we're going to factor by grouping. So I'm going to rewrite this long addition statement so that I can do the whole bracket thing. 4x squared plus 6x plus a negative 10x plus a negative 15. Going 2 at a time. The 4x squared and the 6x have a 2x in common, so we'll take out the 2x, and we'll be left with 2x plus 3. Then we go to the next two, and negative 5 jumps out at me, so take out a negative 5. Mind your signs, that's going to make both of these become positive. So we'll be left with a 2x plus 3. Now, one of the beauties of walking through the factorization process this way is that this method self-checks to a large extent. If the binomial in your parentheses is exactly the same for each of these sets of for each parenthesis, then you've probably got it right. If they're not exactly alike, you need to go back and check your product sum table, check whether you pulled out your signs correctly, check whether you copied correctly from the previous line. There should be no difference at all, down to the smallest detail. Now, we have this 2x plus 3 in common that we can pull out, and we're left with 2x plus a negative 5, which I'm going to write as 2x minus 5. Your last step, and I leave it to you to do this, is to check with FOIL. See if you get back to the original. In a testing situation, you want to do that every time, and so that means you want to practice that in your homework. What you practice in your homework is what you end up doing on tests.